Hey everybody, this is lesson 6-7, exponential functions and sequences. So in the past, we have talked about arithmetic sequences and geometric sequences, where if given any term, you can find its value. And we call that actually an explicit term. So you can figure out any value given any term. Okay, so given the 14th term, what is the value of that number? What we're going to do today is actually talk about recursive rules. And now a recursive rule really means I need to know the prior to. So here, if I know the 14th term, if I want to figure out the 14th term, I just plug it in. Here, if I want to figure out the 14th term, I have to know the 13th or the terms that come prior to this. So for a recursive rule, we need to know previous terms. So that's what we're going to talk about today. Now, we're going to take a look at these formulas in just a second. But if you recall, the arithmetic sequences were simply adding or subtracting, and we were looking for a common difference. Okay? With the geometric sequence, we were multiplying. Now, I guess I could say and dividing, but remember, instead of dividing, we're multiplying by a fraction. And here we're looking for a common ratio. Now, I'm going to come back to these formulas in just a second. So if I take a look here, write the first 6 terms of each sequence, then graph the sequence. So I have my first term, a of 1 is 3. Now, what does all this mean? Well, if I want to find the second term here, that's a of n, I need to add 3, because I want n minus 1, which is, so 2 minus 1 is 1, so I need this term, which is 3. So I have 3 plus 5 is 8. So this n minus 1 is really just fancy for previous term. So if I have the 5th term, I'm looking at the 4th. So a of 3, previous term is 8. 8 plus 5 is 13. My 4th term is the previous term plus my common difference, which is 18. My 5th term, previous term plus 5 gives me 23. And then previous term plus my common difference is 28. Now, when I go to graph these, this is my first term, value of 3. Second term, 8. 3, 13. 4, 18. 5, 23. 6, 28. So what is that going to look like when I graph it? Well, let's take a look. So I have 0, 3, whoops, 1, 3, not 0, 3, 1, 3, there's no 0 term, 2, 8, 3, 13, 4, 18, 5, 23, 6, 28. Do I connect those points? No. But it looks like I have a linear function, and of course, this is also discrete, meaning I am not going to connect those points. So what does this term right here mean? So a recursive equation right here is the previous term plus the common difference. Right here. So my common difference here is 5. Now this one's a little different. So notice I'm multiplying, so I have a geometric sequence here. So my first term is 5/10. My second term is 2 a of n minus 1 is my previous term, so I have 2 times 5/10 is 1. A of 3, 2 times the previous term is 2. A to the 4. 2, whoops, not sure what that means. Sorry about that. So 2 times 2 is 4. A of 5. 2 times previous term is 8. A of 6. 2 times previous term is 16. So this 2 is my common ratio. So if I were to graph this, 1, 5/10, 2, 1, 3, 2, 4, 4, 5, 8, 6, 16. So let's take a look. So I have 0, I did it again, 1, 5/10, 2, 1, 3, 2, so as long as I got a straight line again, 4, oh, maybe not, 4, 5, 8, oh, look at what I have there. Exponential function there, but it is still a discrete function as well, because I can't have 1.5 terms. So now, how can I write a recursive rule for this? Well, the first thing I need to know, is this an arithmetic sequence or a geometric sequence? If I look here, I've got a common difference of adding 7 each time. So my common difference here is 7. So if my function a of n minus 1 plus d, what's my common difference? Well, that's 7. So my function is simply here. A of n equals a of n minus 1 plus 7. That's it. All I need to know is figure out the previous term and add 7 to it. Now here, definitely not subtracting. Looks like I might be dividing. Oh, no, we're not dividing. We're actually multiplying by a third. So my common ratio here is 1/3. So if I have a of the n equals r a of n minus 1, the only thing I know here is my common ratio. So I have a of n is 1/3 a of n minus 1. So the previous term times 1/3 is going to give me my current term. Okay, so it's your turn. Go ahead, hit pause. When you're done, come on back and let's see how you did. All right, give you a second to look these over. Let me know if you've got any questions, and I will happily answer them for you in class. All right, so here's what we're going to do. We're now going to translate between the two. So given one, can you give me the other? So I want to look at writing an explicit rule for a recursive rule. Okay, so that means I want an explicit rule. Now, one of the things that helps me is to write the function first. So let's see, I've got a common difference. So I know that I should have something, whoops, that looks like this. So it looks like I need to figure out a of 1 and my common difference. Well, for this recursive rule, I know that this a of n equals a of n minus 1 plus d is my common difference. So my first term is 9. It's stated right here. And my common difference is minus 4. So I have all the information that I need right here. So if I were to take a look, I'm looking for my common difference, which is negative 4. So I've got my d equals negative 4. So let's replace what we know. A of n equals 9 plus n minus 1 times negative 4. So I have a of n equals 9 plus, let's distribute, so that's actually minus 4n plus 4. So all said and done, a of n, let's see, negative 4n plus 13. I want to point something out. Look at what my coefficient is. Yeah, the coefficient to the explicit rule here is your common difference. Pretty cool, huh? All right, let's take a look here. So I want the explicit rule given the recursive rule. So that means I have a to the n equals a of 1 r n minus 1. So, well, here's this. Now remember, my common ratio is this right here. So I have a to the n equals r times a minus 1. So my r here, my common ratio is 3. My first term is 4 5/10, so I can rewrite this to a to the n equals 4 5/10 times 3 to the n minus 1. Yeah, that's pretty cool, isn't it? All right, let's take a look at the next example here. Okay, so now let's go the other way. We want the recursive rule. So if I want the recursive rule here, let's see, what do I need to know? That's a of n equals a of n minus 1 plus d. Oh, this is not the formula. Oh, wait a minute. Remember, if I go back, there's my d. It's that coefficient. So right here, my d is 6. So I have a of n equals a of n minus 1 plus 6. That's it. Super cool. Now here I want the recursive rule, so let's figure out what I need to know. So I have a of the n equals r times a of n minus 1. Okay, so let's see. I need to find the r, and as you recall, my r, my common ratio is 3. So I have a to the n, or a of n, is 3 times a of n minus 1. All right, it is your turn. Go ahead, hit pause, try these, and see how you do. All right, let's check these out. So for 10, you've got a of n equals 20n minus 65. For 11, a of n is 13 times negative 3, parentheses, to n minus 1. Now here, my coefficient is negative 1. So be careful there. So my d is negative 1. So I have a of n equals a of n minus 1. And then 13a of n equals 4a of n minus 1. All right, so looking at example 5, sometimes there's not an arithmetic or geometric sequence, meaning I am not adding or subtracting the same number to get the next one, or I'm multiplying the same. But what I do notice here is that negative 5 plus negative 4 gives me negative 9. Negative 5 plus negative 9 gives me negative 14. So I can kind of see a pattern here. But what is my rule here? All right, let's see. All right, so this is term 1, 2, 3, 4, 5, 6. So let's see. My first term plus my second term equals my third term. Okay, let me see if this pattern continues. So negative 5 plus negative 9 is negative 14. So I have my second term plus my third term equals my fourth term. So how could I write this like this? Well, if I just use these as an example, so if this is 4 and this is 3, that's n minus 1. And this is n minus 2. Not bad. So what are the next few terms? So let's see. I have negative 23 plus negative 37 gives me negative 60. So the previous term plus negative 60 gives me negative 97. Add the previous two terms, negative 60 plus, negative 97 gives me negative 157. All right, these are a little bit trickier, so let's see how you do. Hit pause, and let's come back when you're ready. But there's a little typo here, so I apologize. This is actually 4, 3, 1, 2, negative 1, 3, negative 4. It's going to make a little bit of a difference there. All right, let's take a look. How'd you do? So number 14, you're adding the previous two terms. 15, same thing. Now here, this pattern does not continue. So we're actually subtracting here. So you got to make sure that pattern continues throughout. Nice job, everybody. Have a great day.